Good morning, everybody. Now, inshallah, grade 10, we are going to study the next lesson after lesson of naming molecules. And before studying this lesson, we are going to talk about the 9th week value, which is time investment, and take care that you must know our time, okay, and you can benefit from each minute. It's okay. Now, inshallah, we are going to complete the sessions that we studied for the second lesson, which is called molecular structure. Molecular structure, okay. And in this lesson, inshallah, we are going to study structure, formula of the chemical compound and resonance. And how can we write the chemical formula of the compound, okay? And how can we differ between the chemical formula of different chemical compounds? Okay, let's go. First, section 3, which is called molecular structure. Okay, structure formula shows the relative position of atoms with a molecule. Okay, listen to this, please.
Section 3, molecular structures. Structural formulas show the relative positions of atoms within a molecule.
Okay, and what I know, what I want to find out, what I learned. What I know that we studied before, the ionic bond. Okay, who can answer me what's meant by ionic bond? Yes? Ionic bond, good. Ionic bond is electrostatic attraction between positive ions of metal and negative ions of another non-metal. Okay, so it's called electrostatic attraction because it's between positive metals and negative non-metals. Okay, so who can answer me what is meant by covalent bond? Yes, excellent. Covalent bond is sharing between mostly two non-metals by either 1 or 2 or 3 electrons. So it's called sharing, okay, without losing or gaining any electrons. And this difference between ionic bond and covalent bond. Okay, who can answer me? Give me an example of ionic bond. Ionic compound, yes. Good, NaCl or sodium chloride. Another example about covalent bond, yes. Good water or H2O that has single covalent bonds. Okay. After that, the essential questions that we are going to study. Number 1, lesson.
Essential question. What are the basic steps used to draw Lewis structures? Why does resonance occur? And what are some resonance structures? Which molecules are exceptions to the octet rule, and why do these exceptions occur?
This is the essential questions that we are going to study. What are the basic steps used to draw Lewis structure? Why does resonance occur? And what are some resonance structure? Listen, and question number 3, which molecules are exceptions to the octet rule, and why do these exceptions occur? Okay, after that, the vocab that we studied before, okay, that's ionic bond that we studied it before, okay, but the new, that's called what lesson?
Structural formula, resonance, coordinate covalent bond.
Okay, this is the vocab that we are going to study. After that, okay, structure formula. What's meant by structure formula? Structure formula uses letters, symbols, and bond to show relative position of the atom. Structure formula, okay? Structure, that what is the structure of the compound and what is the structure of the atoms that form this compound, okay? So, structure formula uses letters, symbols, and bonds to show relative position of the atoms, okay? And this is called what? Molecular formula of pH3. Okay, pH3. pH3, this is a structure formula that we can draw the bond and determine the atoms that form this compound as pH3. pH3 structure formula. Okay, All students must know that hydrogen has one bond, okay, to be completed, has one electrons, okay, needs one electrons to one electron only to be completed. So it makes single covalent bond at this and this and this. But phosphorus has 5, but there are 3. Okay, what about the 2 other electrons? Okay, 2 other electrons that will be drawn in Lewis structure. Lewis structure that we are going to study. It's a Lewis structure. P has what? 1, 2, 3 electrons and 4, 5. The other 2 electrons. As what is the atomic number of phosphorus? Good, 15. So 2, 8, 5. And the outermost energy level of phosphorus has 5 electrons. So 1, 2, 3, 4, 5. It's okay? And to draw the ball and stick molecular formula of this. This is the phosphorus. This is determine the phosphorus atom joined between 3 hydrogen atoms and this structure. And space filling molecular model, this is the space filling molecular structure. So it's what? Molecular formula and structure formula. Lewis structure, ball and stick molecular model that we can made it model of pH3 and space filling molecular model. Understand? So structure formula uses what? Again, lesson.
A structural formula uses letter symbols and bonds to show relative positions of atoms.
It's okay. After that, we are going to move to another slide. Okay. Another slide is that structure formula. Okay, what? Drawing Lewis structure. How can we draw Lewis structure? Okay. Predict the location of certain atoms. The atom that have least attraction for shared electrons, least attraction, will be the central atom in the middle. Okay, in the molecule. Usually, the one closer to the left side of the periodic table, at the middle. All other atoms become terminal atoms at the 2 sides. Terminal atoms. Note, hydrogen is always a terminal atom. Why? Hydrogen is always a terminal atom. Why? Yes, good, because hydrogen needs only 1 electron to be completed. Okay, so it can't be found inside the center of the molecular structure of any chemical compound. Then determine the number of electrons available for bonding. The number of valence electrons. Okay, what is the valence? Valence may be mono, di, or tri, and so on. So we must take care to determine number of electrons available for bonding. After that, determine the number of bonding pairs. Okay, divide the number of electrons available for bonding by 2. It's okay. Listen, please again.
Drawing Lewis structures. Predict the location of certain atoms. The atom that has the least attraction for shared electrons will be the central atom in the molecule, usually the one closer to the left side of the periodic table. All other atoms become terminal atoms. Note, hydrogen is always a terminal atom. Determine the number of electrons available for bonding. The number of valence electrons. Determine the number of bonding pairs. Divide the number of electrons available for bonding by 2.
By 2. Okay. So we are going to move to the next slide. Okay. After that, place the bonding pairs. As what? Place single bond between the central atoms. Okay, and each of the terminal atoms. Single bond as hydrogen that we said. Determine the number of bonding pairs remaining. Subtract the number of bonding pairs in step 4 from the number of bonding pairs in step 3 of bonding pair. Place lone pairs around terminal atoms except hydrogen as we said. To satisfy the octet rule to be completed. Any remaining pairs will be assigned to the central atom. Okay, determine whether the central atom satisfies the octet rule. If not, convert 1 or 2 of the lone pairs on the terminal atoms into double bond or a triple bond between the terminal atoms and the central atom. Okay, remember, carbon, nitrogen, oxygen, and sulfur often form double and triple bonds, either double or triple bond. Take care from this note. Okay, listen again, please. And
Place the bond
observe.
in pairs. Place a single bond between the central atoms and each of the terminal atoms. Determine the number of bonding pairs remaining. Subtract the number of bonding pairs in step 4 from the number of bonding pairs in step 3. Place lone pairs around terminal atoms, except hydrogen, to satisfy the octet rule. Any remaining pairs will be assigned to the central atom. Determine whether the central atom satisfies the octet rule. If not, convert one or two of the lone pairs on the terminal atoms into a double bond or a triple bond between the terminal atom and the central atom. Remember, carbon, nitrogen, oxygen, and sulfur often form double and triple bonds.
It's okay. I'm going to move to the next slide. Okay, atoms within a polyatomic ion are covalently bonding. Polyatomic ions. Okay. The procedure of drawing Lewis structure is similar to drawing them of covalent compound, as we are going to see. The difference is you need to determine the number of electrons available for bonding only. How? By finding the number of electrons available in the atoms present and then subtract the ion charge if the ion is positive, or add the ion charge if the ion is negative. Okay, lesson.
Atoms within a polyatomic ion are covalently bonded. The procedure for drawing Lewis structures is similar to drawing them for covalent compounds. The difference is, you need to determine the number of electrons available for bonding. Find the number of electrons available in the atoms present and then subtract the ion charge if the ion is positive, or add the ion charge if the ion is negative.
Okay, after that, example to know how can we write the molecular formula by this structure. Okay, ammonia is a raw material used in the manufacture of many products, including fertilizers, cleaning products, and explosives. Draw the Lewis structure for the ammonia industry. Okay, observe what happens. First, ammonia molecule consists of what? One nitrogen atom and 3 hydrogen, because its symbol is NH3. So, nitrogen atom and 3 hydrogen atoms, because hydrogen must be a terminal atom. Nitrogen in the central, as nitrogen in the center, because hydrogen, as we said, hydrogen must be found at the terminal because it needs one electron only to be completed. So nitrogen atom will be occur or will be put in the middle of the molecular structure. Okay, find the total number of valence electrons first. How? Nitrogen 1 nitrogen atom times 5, because nitrogen has 7 electrons. Okay, so its configuration will be 2, 5, and the octet rule and the outermost energy level of nitrogen has 5 electrons only. So 1 nitrogen atom times 5 valence electrons, that's the number of electrons which are found in the outermost energy level, divided by 1 nitrogen atom, because ammonia has 1 nitrogen atom only, plus 3 hydrogen atoms as NH3. So ammonia has 3 hydrogen, H3, times 1 valence, because hydrogen, its atomic number is 1. So it needs 1 electron only to be completed. So 1 divided by 1, okay, as the 1 atom of hydrogen, equal what? Equal 8 valence electrons. Equal what? 8 valence electrons. There are what? There are 8 valence electrons available for bonding. It's the first step that we need 8 valence electrons. After that, determines the total number of bonding pairs. To do this, divide the number of available electrons by 2. 8 by 2, okay, equal 4 pairs. So we need 4 pairs to be molecular structure of ammonia. 4 pairs of electrons are available for bonding. After that, okay, place a bonding pair, a single bond between the central nitrogen atom and each terminal hydrogen atom. Single, because hydrogen needs 1 electron only to be completed. Okay, of this NH3. N is the central atom and the 3 hydrogen atoms, 1, another 1. Okay, determine the number of bonding pairs remaining. What are the number of bonds? Subtract the number of pairs used in this bond from the total number of pairs available. So, total number of bonds is 4 pairs total, minus 3. So, 1 pair available only. Okay, 1 pair available only. After that, the remaining pair, a lone pair, must be added to either the terminal atoms or the central atom, because hydrogen atoms can have only 1 bond. They have no lone pairs. Hydrogen have no lone pairs because it needs 1 electron only to be completed. So these 3 hydrogen atoms, completed. Okay, but the nitrogen needs 1 electron. Okay, so needs 2 electrons. Sorry. So place the remaining lone pair on the central nitrogen atom, not hydrogen, as this. So nitrogen has 3 bond with 3 hydrogen atoms and the lone pair 3 with N, because N is its central molecular structure. Okay, each hydrogen atom finally share 1 pair of electrons as required, and the central nitrogen atom share the 3 pairs of electrons and has 1 lone pair providing a stable octet. It's okay. This is the structure of Lewis in the ammonia NH3 compound. It's okay. In this slide, okay, can you think in carbon dioxide? Okay, and we are going to begin by this example in the next session, inshallah. Okay, that's enough for this session, and I hope that all students remember and listen well to these lessons. Okay, goodbye, grade 10.